Good morning. I am Dr.D.Sathya, working as Assistant Professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss a very interesting topic for introduction of electrochemistry. So, have you ever wondered why your phone is battery is drained so quickly, and or why its iron gets in your garden start rusting of some rain? So, in same thing, the electrochemistry is the science that explain these everyday phenomena. At the core, the electrochemistry studies how chemical reactions produce the electricity. That means chemical energy is converted into electrical energy. So, using this design thinking approach, we start by empathizing. What is the empathizing with the real world problems like weak batteries or corroded metals? Then we can define the challenge. So, how can we make batteries long lasting and prevent some rust effectively? That means how to remove the rust, we can ideate it. Then next we ideate the solution using the knowledge of galvanic and electrolytic cell. So what is the anode and cathode are used, so we can see one by one. So do you understand what is this picture? Yes, this is a oxidation and reduction. Oxidation means the loss of electrons and reduction means gaining of two electrons. Yes, here the oxidation, the loss of electrons will be an anode, and reduction in gain of electrons act as a cathode. Why we studied electrochemistry? Just yes. Now we are discussing in batteries in phone and health and environment, the pH sensors in medicine, industry and future relevance. In all field, we are using the batteries and related to the electrochemistry. This is the empathy of our electrochemistry. So connect with the real world problems. Have you ever noticed the mobile train? Yes. The corrosion damage in bridges because of electrochemical reaction happening inside the metals and batteries. What is the define? So define some corrosion resistant for bikes. So it's a develop eco-friendly batteries for the remote areas. That means in rusting of iron we can use some painting or anything. So same thing we can using some cathode reaction, it will be coated by the anode. It will be acting as a thin layer of the iron. For example, we can use for cathodic in copper. Then iron is act as anode. We can deposit the copper in the iron, rusting of iron. So this process is called the resistance coating for bikes. Why do some metals corrode faster than others? How does battery converted into chemical energy into electrical energy? Can we design cell that last longer? So these questions are defined. We can use the define. Why some metals corrode faster than others? Yes, we know about the electrochemical series and electrode potential we have to study. That's why we can study the electrochemistry. And battery is converted into electrical energy to chemical energy to electrical energy. So these reactions in under the electrochemistry. Then we can design the cell in long laster. That means the primary cell we can dispose it within 1 or 2 months. So now the research going on how to the electrolytic will be changed and how will we use the long lasting. So this is the research going on the batteries and electrochemical cells. So we have to study more what is the carbon rod in metal cap. This is some Daniel cell we are using in primary batteries now. So this is the basic diagram for primary batteries. The paste of ammonia, that means the electrolytic solution, and bottom the electric negative, and top the metal cap is a positive. Zinc act as a anode, that means the loss of electrons. Manganese oxide is one of the electrode. So this is the basic diagrams for batteries. How the battery works? So we are discussed how to battery works. This is the cathode and anodic reaction. In center part, the electrolytic. In positive and negative, it's a connect with the voltage. So the anode, the loss of electrons. The cathode will be gain of electrons. The flow of electrons will be converted into the, that means the chemical energy converted into the electrical energy. So what is the prototype? In prototype, nowadays we are using lemon also. It's an electrolytic solution for instead of zinc sulfate solution and anything. So lemon and some apple and a lot of things we are using in nowadays as a act as a electrolytic solution for batteries. The research is ongoing. So what is the application of electrochemistry? Some technologies based on the electrochemistry, different types of application related to the electrochemistry. So sensing, corrosion and organic synthesis, that means electrochemical synthesis, industrial electrolysis, energy conversion and energy storage. So lot of applications is related into the electrochemistry. It's specifically the batteries also, it's a very fast growing approach in electrochemistry. So this is a electrochemical energy conversion in space, in energy storage and material processing and fuel synthesis. That means the energy storage, the fast moving lithium ion batteries and fuel cell. Lithium ion batteries we can use in mobile phones and laptops and all things, and fuel cells, material processing in electro deposition and electrocrystallization. That means we can study the electroplating upcoming sessions, and also the how can the fuel production. So thank you.